Thanks for joining us at Migration 2020. I'd like to turn it over now to Pete Bunce, the President and CEO of the General Aviation Manufacturers Association.
Well, good afternoon, everyone. My name is Pete Bunce, the head of the General Aviation Manufacturers Association, and it's great to be back at the Redbird Migration. I've been to several, and I always think it's just such a fantastic event, and the ability to get so many of the training community to get together and talk about what's so very important to all of us and how we do training throughout the life cycle of any aviator is something I always like to be a part of. And my hat's off to Redbird, Charlie and the team for being able to continue this forum and grow it over the years. And we all learn a lot from it. So what I thought I'd talk about today is something that's got a lot of people very excited, and it's about advanced air mobility. And we've titled it The Next Frontier in General Aviation, and give you a snapshot of what's happening with a perspective as we go through this of how we're going to need to think about training the aviators of the future. So let's level set everybody first. Let's take a look at the population of aircraft that are out there. Obviously, pistons still dominate the population of aircraft, and this is globally. Commercial airliners and biz jets and turboprops, when you add them all together, pretty close to the same. About 31,000 rotorcraft plus out there. And what's really fascinating is to watch how many registered unmanned vehicles that are flying out there in the U.S. As of just last week, looking north of 1,700,000 out there as a population. Right now, we don't have any certified advanced air mobility aircraft flying in the airspace, but it's not going to be long, and I'll touch on that throughout the presentation. Now let's look at the global distribution of those aircraft. North America has the predominance. That's no surprise to anyone. Now this does not include unmanned aerial vehicles, but if you just look at it, the primary market is here in North America. Why? Because we have the infrastructure for it. We in the United States and to some extent Canada and Mexico are aviation nations, and we don't have the rail infrastructure that Europe has. We base getting around our country on automobiles and aircraft, and so the predominance of that population is here, and that's where the predominance of the development of many of the companies that are into advanced air mobility are, even though this is a global effort. And those of you that have watched the news and everything already have seen aircraft flying in China. We've got a lot of development going on in Europe, a lot of testing in Africa and the Middle East. And we know South America, you go to a place like Sao Paulo, has such a robust rotorcraft transportation network built just for people to get in and out of the city that we know that this type of mobility, the advanced air mobility, will be right for that part of the world. So this is truly a global marketplace for where this new development and technology is going. If we look and take a look at disruptive change, and I've talked about in many forums, and some of those of you that have heard me before, no, I'm as excited about this as I've ever been in anything in aviation, and I liken it, and I was too young at the time, but the dawn of the jet age must have been like this. And but we've seen disruptive change in transportation before. If you take a shot of Easter morning in 1900 down Fifth Avenue in New York City, there was only one, the red circle there, only one automobile on that street. Well, it didn't take long for things to change. And if you look 13 years later, the exact same street, can you spot a horse-drawn vehicle? Well, there is one right there. And that's it. So in basically 13 years, the world changed dramatically. And have we seen that in aviation? Well, I would contend that if you look at what happened with glass cockpit technology, that has happened. And most of us have seen this happen, whereas when we first started flying with it in 2003, it was only in a few aircraft out there and look at how rapidly it changed. And by the end of 2008 and the delivery year of 2009, virtually the only way you would get the traditional steam gauge type of aircraft, if you wanted it that way for any kind of basic training, or if you just were a purist and you wanted to fly that way. Otherwise, most people were flying on having glass installed in the cockpit, and obviously flying with glass in portables. Almost everyone does that. So that change happened very rapidly. Now, if we look at what we're seeing out there, there's different, and they're not formal classifications, but what I like to talk about is there's different platforms that we're using hybrid and electric propulsion on. Some will be easier to certify than others because some simply are built on the traditional thrust, lift, weight type of things that we always have used on the fixed wing side and on the rotorcraft side for that matter. But let's talk about fixed wing right now, and let's talk about these conventional structures and what is happening there. Now, we all know, and I have to preface this always, is that burning dinosaurs, when you've got a combustion chamber, whether you're burning jet fuel or whether you're burning avgas, it is the energy density that you have when we're exploding that fuel air mixture and everything is a lot of energy, and it's hard to replicate that and keep all of the things that we have to be sensitive to in aviation, primarily weight, in balance to be able to make it happen. And that's why you can take a conventional airplane like this, try to put an electric motor on it, fill it up with batteries versus fuel, and still you don't get the range and endurance that you do when you're burning dinosaurs out there, just because of what you get in the energy density of a fossil fuel. But we all know that there are great advantages when we look at electric motors as far as maintainability. We can go from a time between overhaul right now of relatively few thousand hours to over 10,000 hours of operations in an electric motor. The reliability is high. There are many things that we can do to bring down the cost of aviation as we switch to hybrid and electric, but we have to always compensate for the type of battery technology that we have currently does provide some limitations in the size of the aircraft and the range of the aircraft. So let's take a look at a few of these designs. So here we take a Beaver. And those of you, I love flying in Beavers. I love flying in flow planes and going out, whether it's in Alaska and Canada, to go fishing, big airplane and everything. So Magna X has done some really innovative things up in Victoria, Canada area. And we've got a video we're going to roll and take a look at just the excitement that I think that you see in the reporter's voice as she talks about this new type of technology. Let's roll the video.
This may look like a normal old seaplane. It's anything but, and it's making history. The world's first test of a fully electric plane that doesn't emit any carbon emissions, very much dependent on clear skies. Pilot, also the head of the airline, who successfully resisted the winds and the nervous anticipation of those watching, despite a charging glitch the night before.
I got behind the controls of the airplane. I'm focused on getting the flight done. I saw people out of the corner of my eye, but it wasn't a focus for me. So it was all sort of business as usual. Only
this business is completely unfamiliar. Harbour Air is aiming to become the world's first all-electric airline, a crowded race to green an industry where emissions are rising faster than all other modes of transport. These few minutes in the air took months of hard work, ripping out its mid-20th century guts and replacing its old motor with an electric one, adding big, rechargeable batteries. The plane still weighs as much as if it were loaded with fuel, and its new motor only has enough battery charge for a short flight. That's why it works for the Seaplane Company that makes short hops into cities near Vancouver. The man whose company designed the motor knows there's a long road ahead, but he wants the electric planes in the air in the next 2 years.
This is the first time this propulsion system flew on this aircraft. What the regulatory body will want to see is that this happens all the time, consistently. What happens when things go wrong?
The certification process will be bumpy, with Transport Canada entering brand new territory. There will be many more test flights before passengers can also hop aboard a fully electric plane. Salima Shifty, CBC News, Richmond, BC.
So Magnex is one company, and the application that they want to use to be able to fly very short haul flights is realistic to do in this type of Beaver airframe. And we all know how much weight and drag we have with an aircraft that has big floats on it, and an aircraft that was designed for a big rotary engine like the Beaver was originally designed. Let's take a look at a few other conventional designs. If we look at what's happened with Zero Avio, when we take a Piper Malibu and we take a look at it here, an ability to go and take a conventional airplane, put an electric motor on it, and still keep the same basic design and look at the aircraft as we saw with the Beaver there is pretty standard. And again, right now, shorter duration capability. Another aircraft, the Pipistrel Panthera, we know it originally flew with a piston engine on board. Now Pipistrel, which is a great Slovenian company, they are modifying the aircraft to be able to operate on this Rotax electric motor. Or it's actually a Rotax conventional engine combined with an electric motor out there. So there are a lot of things going on with hybrid and electric only. And I think all of us that have been looking in the trades probably saw another interesting one with another traditional aircraft coming up here. And Ampere just did a long duration flight and a Skymaster using the conventional piston aircraft as the rear pusher and the electric motor up front. I think they had over 350 miles in their flight demonstration on this aircraft. And so we're starting to push out on the range, and now you're starting also to look at the size of the aircraft, whether you're talking a Beaver or whether you're talking a Skymaster. You know, we're starting to be able to carry more and more passengers out there. So there are limitations still built in, but when you look at hybrids and everything, we're starting to be able to conquer that and all. So those are using legacy aircraft and modifying them with electric and hybrid motors. Now let's take a look at some clean sheet designs. If you look at what Pipistrel has been able to do, again, the Slovenian company that is developing the hybrid Panthera, and you look at what they're able to do with their all-electric aircraft, they were the first using the new Part 23 CS23 rules that we passed a few years ago to be able to certify an all-electric airplane. That's pretty big. That happened back in June of this year. There's good orders coming in for Pipistrel. Hats off to that great team that we have there. If you ever want to read about a great history of a aviation company, look at what Ivo and the team at Pipistrel was able to do back in the days of Marshal Tito and Yugoslavia. They're here in the United States by Aerospace out in Centennial, Colorado, doing some great work with the E-Flyer into the certification process right now. We're working heavily with that company and with the FAA to be able to apply Part 23 and the new methods of compliance and new standards to be able to apply to being able to certify the aircraft. So exciting things happening there. And I think we've got a video right now, some of the latest video of one of the test flights from the E-Flyer. So we'll run that right now. it's always fun to look at people flying out at Centennial. I love visiting out there. I also love being able to go to Slovenia and visit Pipistrel, and I encourage anybody that's never been to either location, Centennial Airport south of Denver or into Slovenia, to see the operations that we do, because they're great trips. We're working with NASA on different versions of a Technam twin that is being modified in various configurations. This is still one that is yet to be completed. This is an artist rendering of distributed propulsion along the front end of the aircraft with propulsors out on the wingtips, looking at the how you can actually do this for when you need power, when you turn off certain engines, how you fly it, how you land it, with differential thrust and everything. There are a lot of exciting things that we're learning with our partners at NASA. And NASA's into advanced air mobility and electric and hybrid propulsion in quite a significant way. And we have always, for the whole time I've been at Gamma, we've talked about reinvigorating the first A in NASA, the aeronautics A in there. And I tell you, we've got great people working with us at NASA that are so excited and as excited as I am about this new revolution in aviation. And they're great partners to have. And we're working on a lot of automation with these different types of platforms as well. Let's take a look. Dyer and Airbus and Safran, two very established, significant companies in business and commercial aviation, working together on the EcoPulse. Again, distributed propulsion on the front end, and looking at how you're going to augment the standard turbine engine up front. So exciting things there. And then if you take a look at Eviation's Alice, this is a fascinating aircraft here. When you look at this capability for regional transportation, 9 passengers, looking at a range of 500 miles plus. Very fascinating. Those of you that saw initial versions of this aircraft, it was a tricycle gear, and you sit there and you go, okay, it's a tail dragger, and you go, why? Well, when I started asking questions of Omer, who runs the company, and we were talking about certification of it, the certification authorities felt that having something solid in the rear of the aircraft, like a tail wheel that's an extended tail wheel, could keep from a mistake being made by the computers or anything else of actually having a prop strike in the rear propulsor. So that's why they designed it that way. So it's kind of very interesting to look at. You think of the DC-3 back at the dawn of commercial flying and everything, and now we're talking about an electric aircraft, but actually a tail dragger in this case. Also, I asked Omar, I go, oh, okay, how are we going to land in a crosswind? You can't do any type of wing low. And he goes, that's because you don't have to. The computers are figuring out, using differential thrust, that you can do this. You can keep the airplane coming straight as you land, and the computer is actually flying it down for a perfect landing each and every time. And you're doing different things of turning on and off motors also in cruise. So there's a lot of things that we can do, and think about the capability of relieving pressure on the hubs of the little regional flights that we have at the hubs now, opening up more capacity for longer haul, and having these types of aircraft fly out of a different part of the airport, or just in short haul flights. Nobody even needs to go to the hubs anymore, but use this great network of airfields that we have ringing our cities around to be able to do that 500-mile range. If you look at the eastern seaboard or our western seaboard, there are a tremendous amount of flights that take place within that 500 nautical mile range. So I'm very, very excited about this technology. Now let's go ahead and take a look at some of the more what I would call exotic designs. We call them vertical lift, and if you look at the eVTOL models, the one thing that differentiates these from a traditional rotorcraft is you don't have the mass of the rotating blades out there that allows you the capability to have auto rotation and things like that. So these are not helicopters. These are aircraft that as they move horizontally through the airspace, they're using different lift forms, using wing forms to be able to generate lift, but all of them have a capability for vertical flight. So there is a big distinction between these and rotorcraft, but as I am working all the time with all of my association brethren, we're working very closely with HAI International because they are the experts on vertical lift and how we're going to go and employ these aircraft in cities using a vertiport concept that's very much piggybacking on the heliport concept, and actually the operational rules and everything as we go forward with this leverage off of a lot of things that happen on both the fixed wing side and the rotorcraft side. On the certification side, we're hoping to be able to, and we think we've got a good path forward with the FAA, to be able to use Part 23, which is the certification for fixed wing light GA with some special conditions and modifications, because that allows us the easiest entry into the airspace using the operational rules that we have now. So you can look at these different designs of members that are in Gamma, and we've got a few examples that, of course, I'm very excited about whenever I get a chance to go see these aircraft. A lot of them are now flying in test. It's just so darn exciting. So let's look at a few. Joby, located out there in California, very innovative team, well-financed. It's exciting to see the automotive companies and Toyota get involved with Joby with a big influx of capital and financing capital. And a lot of these aircraft now are fairly far along into the cert process. So I think it surprises people how rapidly this is progressing and how embedded they are into the certification process with the FAA and our partners across the sea with the EASA and some of our Gamma member companies. So this is a great airplane. I think pretty soon you're going to be seeing videos. These aircraft are flying right now, but the videos are being held close hold, and they'll be released at the time appropriate for Joby. But I'm very excited and been out there seeing several of the aircraft. Take a look at City Airbus. They have a video for us, and let's see if we can run this on their first tethered flight. So now we can take a look, seeing City Airbus fly, and now let's take a look at another European company with much smaller engines involved in it, and that's Lilium. Lilium's been a Gamma member for years, and a totally different design, different look of the aircraft. And let's take a look at this short video. So you can see those different designs, and now we go to the Wisk Cora. A lot of work was being done with a U.S. company down in New Zealand to be able to initially fly these aircraft, and a different concept with Cora and Wisk of being able to fly, let's say, tourists on a passenger flight in around the mountains and having the pilot actually connected, not actually in the cockpit, but actually having a pilot the aircraft externally. And a fascinating concept, and we're working around the operational rules to be able to go and facilitate that. So you can see a lot of very exotic and exciting designs that are moving forward. And then, of course, the Alki, if we're looking at this type of propulsion, there's a prototype flying here using a hydrogen fuel cell. So as we talk about how potentially we can use hydrogen as fuel cell technology, which is obviously very clean, it just, again, is extremely exciting. And there's been a lot of buzz, especially in Europe right now, about the use of hydrogen propulsion for different types of vehicles. A lot of you have seen Volocopter. There is a prototype flying in Dubai right now, and using small electric motors with small propellers, really, to be able to move this on that upper ring there, and seeing this aircraft fly is also exciting. So you can tell right now the number of designs is just truly daunting. Each one of these with different flight characteristics, which now very much impacts how we're going to train pilots and operators in the future. And of course, some very, whether you want to call them Jetson or Star Wars or any of the sci-fi shows and everything that we've grown up watching, Pipistrel's 5-seat aircraft really looks like a totally radical design. And as I said before, Pipistrel's got one electric aircraft certified, working on a hybrid with the Panthera, and now this is their design concept for a larger passenger airplane. So we're excited about that. If you take a look at Bell's Nexus, take a look at that cockpit on the left. If that is not out of some kind of Star Wars movie or something like that, I don't know what else is, especially that shot looking at it at night. But Bell has prototypes flying. The city fair of Dallas-Fort Worth down there is very forward-leaning because we have great people like H. Ross Perot Jr. and folks down there that have gotten the city fathers together to say, we want this. We want to be able to move this technology forward and be one of the first cities to be able to have advanced air mobility, moving people around in that metroplex. So we're very excited about this, and of course our great rotorcraft manufacturers, Bell and Airbus Helicopter, and so much of the infrastructure for that are down in that Dallas-Fort Worth area. So a lot of expertise in that area, along with our partners at the FAA. And then, of course, if we look at a company like Embraer, which has done so phenomenally well in a short time to be able to develop their array of business jet aircraft, now very heavily in Embraer X. In fact, they just made an announcement very recently about another whole new division that's working on advanced air mobility. So this is a look at their design. They're working and have extremely competent engineering team going into this. And then we take another exotic design, the Paiseki, this compound commercial helicopter, where you're looking at what I talked about before. You can be very efficient with a wing out there, and then you have a pusher type of system on the rear boom and a rotor on the top that you vary the speed of and the use of that as you move forward, using a lot of power to be able to get airborne, but then you don't have to have as much to be able to maintain the cruise flight because you got that big lifting device out there. So there's just so many designs, and all of you I know will think about the kind of training that we're going to have for the different pilots to operate these different vehicles. We're going to talk about that in a second. Are there people excited about it? I mean, you can't open up a trade magazine. You can't open up really a finance magazine without seeing a lot of interest toward that. And it should come as no surprise that whether it's Toyota, Hyundai, General Motors, the automobile companies are getting very excited in this. If you think about where the next frontier is in mobility, and you think about the fact that we as aviators get to operate in 3 dimensions versus 2 dimensions on the ground, a lot of the hurdles for us to get these vehicles into the air and operating are easier to overcome than you do when you're working in 2 dimensions, when you've got much more, you have less freedom of movement, and you have a lot more things that you can't predict, like somebody walking off and stepping off, jaywalking into a street, and the sensor arrays that you have to do to be able to do that. Where in the air, even though we're traveling faster, closure rates are higher. We have sensor technology and computer processing power to be able to allow us to do sense and avoid in that 3rd dimension that on the ground we don't have that capability to do. So there's a lot of excitement for this, and obviously with this type of mobility, when you generate that type of excitement, there is some real money coming into the industry to being able to go and make the type of investments to be able to allow these companies to move very quickly into the certification processes. So that means jobs, that means more excitement for our industry, more people, more requirements for pilots and mechanics. So there's a whole ecosystem that goes with this as we proceed on to a future that's coming more rapidly than people realize. So we formed what we call the Gamma Electric Propulsion and Innovation Committee back in 2015. We started with 11 companies, and one of those being the government entity, NASA, our partners there. And this grew rapidly. We wanted to have a place where companies, traditionally to be a member of Gamma, you had to have a certified product. And so we had a mix of some certified companies and some non-certified, but we wanted to create a membership structure in the associate category where we could get these companies corralled together to start working with one another, because all boats rise at high tide, and if they work together like all of our traditional Gamma member companies, we're going to be able to progress and produce a level playing field to compete, but also speed the adoption of these vehicles into the airspace and all over the planet. So this is what it looked like in 2015. And also take a look at what Bell Helicopter's logo was back in 2015. Now let's just take a look at what that looks like today. Toward the end of 2020, we have 81 member companies participating, and about in the same place in the graphics. Note that Bell Helicopter is no longer Bell Helicopter, it's Bell. And also note that in the logo there's a dragonfly. That is done purposely. Look underneath the Bell, you see the Hyundai logo for their motor group. They just joined in this effort. A lot of traditional manufacturers in this space. Why? Because there's business opportunity. Everyone knows now that this is coming, it's real, there's high potential, and they want to be part of it. And that's why I get just so excited about what our future looks like for aviation. And the proof is in the pudding when you just look at this great group of companies, and it's growing all the time. At our recently concluded Gamma board meeting, we had 2 more join this group, and since then we've had pulses from a few more that want to get involved. So we're very excited about what's happening in this category. Now, we can't do anything without regulation. And back when we started the Gamma Epic Committee, we took a look at the first quarter in 2016 of how the regulatory structures looked across the planet and the major aviation authorities, whether that's ANAC, which is the Brazilian authority, the CAAC in China, EASA, of course, in Europe, the FAA, and Transport Canada. And if you take a look at that, there wasn't a whole lot of encouraging news in 2016, but things changed rapidly. And the color codes there are red, where there isn't any regulation, yellow, where it's just starting, the hash green means we're getting closer. And as you see, by 2017, we had some green show up. China being very progressive, EASA, but work starting with the FAA and that. And it looked better than 2018, more green showing up. And as we advance to where we are today, finishing up Q3 2020, you can see that we've got a lot of rules established, and the regulatory environment is getting very well established, both with the EASA and with the FAA. We don't have as much green with the FAA, but it's trending that direction, and we're working hard with our partners at the FAA to be able to establish the conditions to be able to get these aircraft into the airspace structure. So I'm very excited about the progress, but it's something that takes a lot of work and a lot of dedication from all the GA associations and all the companies that want to be involved there to work with our partners at the FAA, use the tools that are given us with especially the consensus standards on a global and international basis to be able to go ahead and move this rulemaking forward so we can get these aircraft into the air and passengers on board. So one of the things that's the challenge for all of you and the training community, and it goes to also those that build and design simulators, is how do we keep the pilot in the loop and work with these autonomous systems in aircraft that have so many variances in design, but also don't fly like a aircraft that we're familiar with, whether you're a rotorcraft qualified pilot or a fixed wing pilot. These aircraft that I've been talking about, a lot of them that don't have the conventional design, these more in the eVTOL category of advanced air mobility, really fly differently. You don't have the coordinated turn of roll and yaw using combination of ailerons and rudders in some of these aircraft that, depending on what the computer is telling you, it may just pivot in the yaw axis. It may just use differential thrust to do that. But you as the pilot, you're telling it what you want it to do, but you're not actually moving control surfaces to be able to make it do what you want it to do. The computer is doing that for you and with the inputs that you give to it. What does that mean? Well, in the initial tranches, we're going to have to be able to give this community, the eVTOL or advanced air mobility community, a baseline of pilots with a private pilot's license. But then each one of these aircraft with its unique design is going to take a lot of training in that specific design to be able to make sure that the operator, the pilot, the operator is able to competently fly that machine into the type of missions that we need to fly. So we are in this very interesting time in the evolution of aviation where that human-machine interface is really being explored to see what we can do. And let's take a little deeper dive into that. A few years ago, we just sat down with our friends at the FAA and at NASA, and we started mapping out, okay, what is a pilot? Well, we give them some knowledge, him or her, some flight training and experience. That experience is a very important element of that. Make sure that they've got a good medical, and we produce a pilot out there. That was very simple. We know that's a very complex process, and we all ought to be proud of what we can do there. But also, it's changed on how we produce that pilot over time. A lot of us that are older, we flew with federated cockpit aircraft. And now most of the machines that we jump into are integrated cockpits. But as we work towards simplified vehicle operations, and if you think about the vanguard of simplified vehicle operations, think about the Garmin Autoland system that just got certified on 3 different platforms. The Piper M600, the Dyer TBM, and also with the Vision Jet, aircraft that have auto throttles, and there is a lot of demand for that. So we're talking about a integrated cockpit with a button that simply then becomes a simplified cockpit that, let's say a passenger, the pilot has a heart attack, is incapacitated, the passenger now pushes the button and it becomes a simplified cockpit. That's pretty dramatic. And then how long will it be before at some point in there, we actually won't have the human in the aircraft itself? Now, will that happen very soon for aircraft that are carrying passengers? It's going to be a while there. But if you think about carrying cargo, or you think about an aircraft that's built to carry passengers some parts of the day, but may be used because of that great capability of using electric motors and the fact of its long time between overhaul, efficient use of that vehicle may be hauling boxes at night or in the wee hours of the morning, and then going back to carrying passengers during the day. So a lot of capability with these types of machines. And obviously what happens is the pilot workload starts to decrease and the automation has to increase. Now, where are there limits to that? Well, if you look at simplified vehicle operations, we also work with this team, NASA and the FAA, and started binning, what does a pilot do? And if you look at all the tasks that a pilot does, both before they get into the machine and start it up, on to post-flight and everything, there are a lot of functions. And we try to break these down and say, okay, if we break them down and take a deep dive look at them, let's look at what the machine can do and what the human can do. There was a fascinating piece that was sent to me a few weeks ago by Charlie's dad, Jerry Gregoire, and I think it was titled, "Can the Computer Ever Replace the Pilot?" And I think that's close to the title and everything. And I encourage you all to take a look at it because it's very thought-provoking. And I couldn't agree with Jerry more when you watch it. You know, despite all of the talk about advances in artificial intelligence and AI out there working, there are some things that the computer just cannot do as well as the pilot. So let's take where all of these different pilot tasks that we have here, and what we've done is we've broken them down in what we call the deconstructed pilot. We've sat down with the FAA and we've talked about where are we in 2020 with these different tasks on what the computer can do well and what the computer can't do well. Planning and decision making, the computer's okay. It can do some great systems management. It can do some great basic airmanship. We're figuring out, like Airbus just recently did. I showed the headline the other day. They flew a totally autonomous flight in Europe from takeoff to landing with a larger transport category aircraft. We're getting there on takeoffs and landings. It knows terminal procedures very well, really knows, the computer knows how to navigate well. On communications, heck, I can't get Siri to understand me half the time. Not real well there. Detect and avoid, we're getting better. Emergency procedures, the big dog out there and everything. Can a computer, no matter how good AI is, ever predict what human behavior, especially of passengers when they're stressed in an emergency situation or coming down in a parachute that's been deployed? Can it ever do that prediction out there? These are all questions for us. So what our job is to figure out what the computer can do well, and then what we need to focus on the operator of these vehicles being able to do. And once we figure that out, then how best to train them to be able to do that. And that's why we will need the help of this entire community. So what did Gamma do a few years ago? Actually, it was last year. We convened a lot of smart people that both are building these machines and that are training providers to get together and try to do a first look at the construct of simplified vehicle operations and the actual training of the operators that do that. So we're making this document available to you all to just take a look at and provide us some feedback. We gave it to the FAA, we gave it to EASA, we've gotten good feedback, and it's an initial look. And then with that, we also produced back in February of this year, before COVID, a look at transitioning to the eVTOL aircraft. And one of the things that I just pulled out to show you here is something that we all need to realize is that each of these aircraft, we probably won't call it a type rating, but they're so different that we're going to have to take that pilot with a PPL and get them familiar with that specific vehicle. But those vehicles have relatively short endurance capability out there. And in a way, and because of the way they are designed, a simulator is the perfect tool to be able to train. We can do virtually everything in the simulator, train them a lot like we do type ratings on advanced aircraft now. I mean, I got a type rating in a Premier 1 and I got the rating all in the simulator. And these vehicles even lend themselves to do that even more. But we can do things in the simulator that we can't simply do safely while we're airborne, and the duration of these flights are so short, it would take a while to be able to do that in a realistic environment of training anyway. So why not do a lot more in the simulator? So again, we have another document that we're making available to everybody here to be able to take a look at and give us some feedback, because it's going to take all of us working together to be able to chart what our future is of flight training and simulation as we enter into this new world. So these new products, this is quite a potential market. You know, $80 billion market by 2050. So we're talking 30 years away. It's huge. And that's why a lot of people are investing in it. A lot of people are getting excited about it. But just think what it can do for mankind of mobility. That's clean mobility, get us off the roads. It's going to be safer. And, you know, those of us that are old enough to remember the Jetsons and everything, that dawn of that Jetson age is rapidly approaching us. So I am as bullish about this as Leonardo da Vinci was many centuries ago. And you just think about how prophetic his words were. And if you have to actually look at his design that he drew back then, not a whole lot different than some of the exotic designs that we're seeing out there. But all of us are in this industry because we have a passion for it. We love it. And most of all, we love the people in this industry. So I am so bullish about the future, about what we're seeing right now, of being able, even during COVID, to walk out to an airport and see people happy because they're actually getting out of their homes and flying, seeing the flight schools full with training pilots out there. And that demand and that excitement is only going to grow over the next few years. So it has been a pleasure to be with you, and I hope to be able to converse with you in the coming weeks and months about this new era in aviation. Thank you, Charlie, for letting me be a part of this, and you all have a great day.